Factoring a polynomial when you know that one of the factors is a binomial is like thinking about division using the synthetic approach. So in this case, we know that our r that we place in the box is -3. And our coefficients from our polynomial written in order would be 1, 5, 5, -5, and -6. We drop down the 1 and we begin our multiplication process. -3 times 1 is -3 plus the 5 is 2. 2 times -3, -6 plus the 5 is -1. -1 times -3 is +3 plus -5, -2, and finally +6. So in fact the remainder is 0, which is what we expected given the fact of the knowledge that that is supposed to be a factor. Now this answer would depress down to a polynomial of degree 3 since the original was degree 4. The question is now what do we do? We are going to apply our rational zero theorem so that we know that the possible zeros would need to be factors of the ratio p over q according to the rational zero theorem. So the four choices that we have would be positive, -1, positive, -2. And hoping that we are selecting the correct one, let's try the possibility of +1. Continuing then with bringing down the 1, 1 times 1 is 1, 2 plus 1 is 3, 1 times 3 is 3, added to -1 leaves us with a 2, and 1 times 2 is 2, and again following our remainder bar we have a sum of 0, which tells us that in fact 1 is a 0, and we now have found a factor. Knowing that 1 is a 0, the factor that we have found is x minus 1. Not only that, but we've now depressed our polynomial down to a quadratic, having the coefficients 1x squared plus 3x plus 2. What we can do from that then is to see whether we can simply factor this successfully, and in fact x plus 1 times x plus 2 would be a correct factoring. These two factors, in addition to the one we've already found, would answer the question, what are the remaining factors of this original polynomial?